Welcome back to AgriCraft, the channel where we explore the future of farming and uncover the incredible stories behind the food you eat. I'm your host, and today we're diving into one of the most innovative agricultural operations you've probably never heard of. We're talking about millions of shrimp being raised not in the ocean, but in the middle of salt deserts, using cutting-edge technology that's changing global seafood production forever. Here's the stunning reality. In the arid regions of the Middle East and parts of the American Southwest, shrimp farms are producing over 40,000 metric tons of premium shrimp every single year, using technology that would have seemed impossible just 2 decades ago. We're talking about Biofloc shrimp farming, a revolutionary system that turns the traditional rules of aquaculture completely upside down. These aren't your grandfather's fish farms. These are high-tech agricultural installations producing some of the cleanest, most sustainable shrimp on the planet, destined for dinner tables across America and beyond. But how do you raise tropical shrimp in a desert? How do you create a thriving ecosystem in one of the harshest environments on Earth? And how has this become one of the most profitable ventures in modern agriculture technology? All will be revealed in this video. To understand why desert shrimp farming matters so much, we need to step back and look at the bigger picture of global seafood. For decades, shrimp farming has been concentrated in coastal regions like Southeast Asia, India, and Central America. These traditional farms rely on proximity to ocean waters and humid tropical climates. But there's a problem. Coastal real estate is expensive, environmental regulations are tightening, and many traditional farming regions are reaching their capacity limits. Enter the desert. The Biofloc shrimp farming revolution started gaining real momentum around 2008, when agricultural entrepreneurs realized something revolutionary. You just need the right technology, controlled environments, and a deep understanding of shrimp biology. The innovation was born out of necessity. As coastal farmland became scarcer and more expensive, farmers and agricultural engineers asked themselves a radical question. What if we could create perfect conditions for shrimp growth anywhere on Earth? Today, countries like Saudi Arabia, the United Arab Emirates, and parts of Arizona have become unexpected shrimp production powerhouses. Saudi Arabia alone now produces over 8,000 metric tons of shrimp annually from desert operations. That's not a small number. That's serious agricultural production happening in one of the world's most challenging environments. What makes this even more remarkable is the sustainability angle. Traditional shrimp farming often requires removing coastal mangroves, which are critical ecosystems. It can generate significant water pollution and disease outbreaks that devastate entire farms. Desert Biofloc farming eliminates these problems entirely. The water is recycled. The environment is controlled. Disease prevention is systematic. This isn't just profitable farming. It's agriculture done right for the 21st century. The numbers tell the story. The global shrimp market is worth approximately $55 billion annually, with demand growing at about 7% each year. American consumers alone eat approximately 4.5 pounds of shrimp per person every year, making us one of the world's largest shrimp markets. But here's what's fascinating. Most of that shrimp is imported. By developing domestic production capacity through innovative desert farming, the United States is becoming less dependent on international supply chains while supporting rural innovation and creating thousands of agricultural jobs. These desert shrimp operations aren't just impressive from an agricultural standpoint. They represent a complete rethinking of what's possible in farming. They're putting American agribusiness on the cutting edge of global food production, competing directly with established powers in Southeast Asia, while maintaining higher standards for food safety, worker conditions, and environmental responsibility. Before we get into the nitty-gritty of how these farms actually operate, we need to understand the core technology that makes it all possible. Biofloc farming. This is genuinely revolutionary stuff, and it fundamentally changes how we think about aquaculture. In traditional shrimp farming, you'd have massive ponds connected to natural water sources. You'd stock them with shrimp, and hope the natural ecosystem provides enough food and maintains adequate water quality. It's passive, it's unpredictable, and disease outbreaks are catastrophic. Biofloc farming flips this script. The system creates artificial microbial communities, tiny living ecosystems suspended throughout the water column. These communities consist of beneficial bacteria, algae, and microorganisms. The shrimp eat these microorganisms as their primary food source. The microorganisms feed on the shrimp's waste products, particularly nitrogen compounds. It's a closed-loop system, a biological cycle that regenerates itself continuously. The beauty of Biofloc technology is that it allows for extreme control. Farmers can manage temperature, salinity, oxygen levels, and pH with precision. They can monitor bacterial colonies in real time. They can prevent disease before it starts. This level of control is why these farms thrive in deserts, where natural conditions would otherwise be impossible for shrimp production. The system is also dramatically more water efficient than traditional methods. A conventional shrimp pond might require massive water exchanges several times daily, consuming enormous quantities of fresh or salt water. A Biofloc system recycles up to 95% of its water. This is absolutely critical when you're farming in a desert where water is precious and often expensive. Our journey into shrimp production begins not in the desert, but in carefully controlled breeding facilities. The shrimp we're raising aren't wild-caught. They're bred specifically for aquaculture, selected for fast growth, disease resistance, and adaptation to intensive farming conditions. The foundation of everything is the broodstock selection. Agricultural specialists choose parent shrimp with superior genetics, looking for traits like rapid growth, low mortality rates, and efficient feed conversion. These premium breeding shrimp are housed in special conditions, fed optimized nutrition, and maintained at precise temperatures and light cycles that encourage reproduction. When shrimp are ready to breed, they produce millions of eggs. These eggs are collected and transferred to specialized hatchery tanks. Here's where the precision begins. Temperature is maintained at exactly 28 to 30 degrees Celsius. Salinity is carefully calibrated. Specialized larval food is provided at precise times. The hatchery team uses agriculture technology that includes automated feeding systems and continuous water monitoring equipment. The larvae, called nuclei, are microscopic when they first hatch. Over the course of approximately 25 to 30 days, they develop through multiple stages, growing larger and developing the body structures needed to become juvenile shrimp. The survival rate in a well-run hatchery is typically between 60 and 80%. The juvenile shrimp, now called post-larvae or PL, are graded by size and quality. Only the healthiest specimens move forward to the nursery phase. The nursery phase is absolutely critical. These juvenile shrimp are still incredibly delicate. They're moved to shallow, heavily managed tank systems, where conditions are carefully controlled. The water is filtered constantly, feeding is frequent and precise. Disease monitoring is intense. Any sign of illness, stress, or poor conditions results in immediate intervention. During this nursery phase, which lasts approximately 20 to 30 days, the shrimp grow from about 2 millimeters to around 15 to 20 millimeters. This might sound like a small growth in absolute terms, but it's absolutely critical. These young shrimp are developing the robustness they need to survive the transition to production ponds or raceways. Quality inspection happens constantly at the nursery stage. Trained technicians examine samples of shrimp regularly, looking for disease signs, assessing growth rates, and checking for any environmental stressors. Every aspect is recorded and analyzed. If a batch isn't meeting targets, the feeding protocol might be adjusted, or the water chemistry might be fine-tuned. The breeding and early cultivation stages are where the entire operation's success or failure is determined. Get this phase right, and your production numbers soar. Get it wrong, and you lose everything. This is why the biggest successful operations invest heavily in hatchery technology and employ experienced breeding specialists. These professionals represent the foundation of the entire industry. Now we transition to the production phase, where the young shrimp grow from teenagers to market-size adults. This is where desert biofloc farming becomes truly spectacular. Unlike traditional shrimp farms with sprawling pond systems, modern desert operations use highly engineered production systems. The most advanced facilities use what are called high-density recirculating systems, or HDRS. These are massive, climate-controlled buildings or outdoor tank complexes containing hundreds or even thousands of individual raceways. Each raceway is typically between 30 to 100 meters long and 3 to 5 meters wide. From above, they look like a grid of rectangular pools, but the sophistication inside is extraordinary. The water in these production systems is continuously circulated through multiple treatment stages. First, solids are removed through mechanical filtration. Then the water passes through biological filters where beneficial bacteria colonies thrive. These bacterial communities are the heart of the biofloc system. They're consuming the ammonia and nitrogen compounds produced by the shrimp, converting them into forms that are either less toxic or can be used as nutrients by the system. Temperature control is automated. Most desert operations maintain water temperature between 28 and 32 degrees Celsius, which is the optimal range for growth. In winter months, this requires heating. In summer, it requires cooling. Some facilities use geothermal energy or solar systems to manage these costs, making the operation more sustainable and economically viable. Oxygen levels are managed through diffused aeration systems. Thousands of tiny air bubbles are introduced into the water continuously, ensuring that dissolved oxygen stays above critical thresholds. Sensors throughout the system monitor oxygen in real time. If levels drop, alarm systems alert staff and increase aeration automatically. The stocking density in these biofloc systems is impressive. Traditional shrimp ponds might hold 50 to 100 shrimp per square meter. High-density biofloc systems can support 300 to 500 shrimp per square meter. This is possible because the biofloc system continuously regenerates the water quality and provides constant food sources. More shrimp in the same space means dramatically higher production per facility. Feeding in biofloc systems is actually semi-continuous. The shrimp feed partially on the biofloc organisms, but they're also given supplemental pellet feed. Automated feeding systems dispense pellets at regular intervals throughout the day and night. These systems can be programmed to adjust feeding based on water quality parameters, growth rates, and other factors. A well-calibrated feeding system can reduce waste and dramatically improve feed conversion efficiency. Disease prevention is where biofloc farming truly shines compared to traditional methods. The controlled environment, combined with continuous monitoring, means diseases are caught and treated before they can spread. Professional staff perform regular health checks on random samples of shrimp. If any problems are detected, the entire system can be treated with targeted therapeutics. The isolation of the system means that problems in one facility don't immediately threaten others. The labor required to manage these systems is surprisingly modest considering the scale of production. One facility producing several thousand metric tons annually might have a core management team of 15 to 25 people, plus seasonal workers for harvesting. These roles are highly skilled. They require training in aquaculture biology, engineering, water chemistry, and animal husbandry. This is creating genuine agricultural careers in regions that have historically had limited opportunities for advanced farming employment. Production in biofloc systems typically takes between 100 and 140 days from stocking post-larvae until harvest-ready shrimp. When shrimp reach market size, typically 15 to 20 grams, it's time for harvest. The harvest process is carefully planned. Most facilities schedule harvests during cooler parts of the day to minimize shrimp stress. The first step involves reducing the flow of water through the raceway. As water volume decreases, the shrimp become increasingly concentrated. Some facilities use gentle netting, while others employ specialized harvesting equipment that gently moves the shrimp into collection tanks. Once collected, the shrimp are immediately transferred to chilled water tanks. This rapid cooling serves multiple purposes. It relaxes the shrimp, it slows their metabolism, and it preserves quality. Temperature control at this stage is absolutely critical. Shrimp quality degrades rapidly if they're not properly chilled within minutes of capture. Transportation from the farm to the processing plant must be extremely fast. Most operations maintain close relationships with processing facilities located within 2 to 4 hours drive from the farm. During transport, the shrimp are kept in specialized containers with ice or refrigerated circulation. If shrimp spend more than a few hours outside optimal temperature conditions, quality suffers and the product becomes unsuitable for premium markets. The processing plant receives the catch and immediately begins quality assessment. Samples are tested for freshness, size, consistency, and any signs of disease or deterioration. The shrimp are sorted by size and quality grade. Modern sorting facilities use optical scanning technology that can differentiate shrimp by size with extraordinary precision, feeding data to conveyor systems that automatically separate shrimp into size categories. The shrimp then move through the processing facility on conveyor belts. In the washing and cleaning phase, the shrimp pass through multiple stages of water cleaning. First, they're rinsed to remove any debris or farm sediment. Then they're passed through sterilization tanks that eliminate surface bacteria without damaging the shrimp. Some facilities use UV treatment or chemical sanitizers in this phase. Hygiene standards at this stage are absolutely critical. The processing facility must maintain standards that exceed government food safety regulations. Next comes deheading and peeling, if that's what the market demands. Automated deheading machines can process thousands of shrimp per hour. Each shrimp is positioned by mechanical systems, and precise cutting removes the head. The peeled shrimp then move through additional cleaning stages. Some facilities have switched to mechanical peeling systems, while others employ skilled workers who hand-peel premium shrimp for specific markets. The deveining process removes the digestive tract, which improves appearance and palatability. Automated deveining machines work on the same conveyor systems, making precise incisions and removing the vein without damaging the meat. The precision of modern machinery is genuinely impressive. Quality inspection happens multiple times throughout processing. Trained personnel examine samples from batches continuously. They assess for freshness, color consistency, proper size, and any defects. Only shrimp meeting strict standards move forward. Any substandard product is rerouted to different market channels or further processing. After initial cleaning and processing, the shrimp move to the freezing phase. This is where industrial technology really becomes apparent. Modern shrimp processing plants use several different freezing methods, each optimized for specific market demands and product formats. Individual quick freezing, or IQF, is the most common approach for premium products destined for American markets. The shrimp are arranged on conveyor belts that pass through extremely cold tunnels. Air temperatures in these tunnels can reach -35 to -40 degrees Celsius. In IQF systems, individual shrimp freeze completely within approximately 15 to 20 minutes. Block freezing is used for some products, particularly those destined for food service or further processing. In this method, large quantities of shrimp are packed together and frozen as a solid block. This is more economical than IQF for certain market channels, though it doesn't preserve individual shrimp quality as well. Once frozen, the shrimp enter a sorting and grading phase. Automated systems weigh shrimp and sort them into precise categories. American importers and processors require extremely consistent sizing. A shipment might be graded as 16 to 20 count, meaning 16 to 20 shrimp per pound, or 31 to 40 count, meaning 31 to 40 shrimp per pound. The precision required is remarkable. Each frozen shrimp is weighed and sorted into the correct category, with less than 2% variation from the target count range. The sorted shrimp are then packed into various formats depending on their destination market. Some are packed into 5-pound blocks, wrapped in vacuum-sealed plastic. Others are packed into larger bulk formats. Labeling is applied with full traceability information, including farm identification, harvest date, pack date, and product specifications. This labeling ensures food safety compliance and allows for complete product tracking from farm to consumer. The packaging phase uses automated systems that work with impressive speed and precision. Shrimp are fed into machines that portion them into the required weight, seal them in plastic, apply labels, and stack them for shipping. A single packaging line might process 30,000 pounds of shrimp per day. Temperature control never breaks throughout this entire process. The shrimp move from the production facility in chilled containers. They enter the processing plant where temperature is maintained at 0 to 4 degrees Celsius. They're frozen at -35 degrees. They're then transferred to frozen storage rooms maintained at -18 degrees or colder. The entire cold chain is monitored continuously with automated sensor networks. If any zone's temperature deviates outside acceptable parameters, alarms alert staff immediately. The frozen packaged shrimp are now ready for distribution. They're loaded into refrigerated containers and transported to distribution centers. Some go directly to retail chains. Others go to food service distributors. Some are destined for further processing in facilities that produce breaded shrimp, shrimp scampi, or other value-added products. The distribution network for desert farmed shrimp is genuinely impressive. A single large facility producing 5,000 metric tons annually requires sophisticated logistics infrastructure to get product to market efficiently. Major shrimp processing facilities often operate their own distribution networks or partner with established seafood logistics companies. The frozen product is packed into standard shipping containers, with approximately 20 to 22 metric tons of product per container. These containers are loaded onto refrigerated trucks for transport to ports or distribution hubs. Many desert shrimp operations are located relatively close to major ports. Saudi Arabian operations can ship to the port of Dammam or port of Jeddah. American desert operations in Arizona or Texas have access to major distribution hubs and rail networks. From these departure points, shrimp destined for American markets are shipped in refrigerated containers aboard container ships or transported by refrigerated trucking. The supply chain is optimized for speed. Modern logistics companies can deliver frozen shrimp from a Middle Eastern processing facility to an American distributor within 10 to 14 days. From the distributor, product reaches retail stores within another 5 to 7 days. American retailers receive weekly shipments of fresh frozen shrimp. The product arrives at distribution centers, where it's inventoried and sorted for delivery to individual stores. A major supermarket chain might receive several pallets of shrimp products weekly, representing thousands of pounds of product. From the retail shelf, shrimp enter the consumer market. Americans purchase shrimp through grocery stores, seafood markets, restaurant suppliers, and online platforms. The cold chain is maintained throughout. Consumers take shrimp home where it remains frozen until preparation. The tracking and traceability systems are remarkably sophisticated. A barcode on each package contains information about farm location, harvest date, processing plant, and pack date. This allows retailers and consumers to trace their shrimp back to the specific farm where it was produced. In case of any food safety issues, product can be located and recalled quickly and efficiently. Some premium operations have begun selling directly to consumers through online channels. These facilities market their desert-farmed shrimp as locally produced, sustainably raised, and superior in quality to traditional imported shrimp. This direct-to-consumer channel offers higher profit margins and allows these operations to tell their sustainability story directly to consumers. Food service channels are equally important. Restaurant suppliers purchase bulk quantities of frozen shrimp, typically in larger pack formats optimized for commercial kitchens. Premium restaurants often feature the origin of their shrimp on their menus, highlighting that their product comes from advanced agricultural operations rather than traditional coastal farms. This marketing angle appeals to increasingly sophisticated American consumers. One of the remarkable aspects of modern shrimp operations is how comprehensive the value extraction has become. In earlier eras, shrimp processing generated significant waste. Modern facilities have largely eliminated this inefficiency. The shrimp heads and shells removed during processing are no longer wasted. They're sold to processors who extract chitin and astaxanthin, valuable compounds used in pharmaceuticals, cosmetics, and nutraceuticals. A 1,000 metric ton shrimp harvest might generate 200 to 250 metric tons of shells and processing waste. This material, worth approximately $500 to $1,000 per metric ton, represents significant revenue generation. Astaxanthin is particularly valuable. This is the natural pigment that gives shrimp their pink color. When extracted and concentrated, it's sold as a premium supplement ingredient, valued at approximately $2,000 to $3,000 per kilogram. A single large processing operation might extract hundreds of kilograms annually. The protein-rich shells are also processed into shrimp meal, which is used as ingredient in animal feeds, particularly for poultry and pet food. This creates a secondary market and additional revenue stream. Water from the Biofloc system, even after treatment, contains valuable nutrients. Some facilities use this nutrient-rich water for irrigation of crops and adjacent agricultural operations, creating a circular economy where waste from one operation becomes input for another. This level of integration is rare but increasingly common at the most advanced facilities. The sustainability advantages of desert biofloc farming are substantial compared to traditional methods. Traditional coastal shrimp farms often require clearing mangrove forests, which are critical ecosystems and carbon sinks. Desert operations eliminate this environmental impact entirely. The water recycling means shrimp farming consumes 95% less fresh or salt water than traditional methods. Some operations use treated wastewater or brackish water unsuitable for other purposes, further reducing their environmental footprint. Disease prevention through the Biofloc system means antibiotic usage is dramatically reduced compared to traditional farms. This has significant environmental benefits, reducing antimicrobial resistance in waterways and ecosystems. The contained systems prevent escape of farmed shrimp into wild populations, which can devastate local ecosystems through genetic contamination and disease transmission. Carbon footprint is becoming an increasingly important metric. Some desert operations have implemented renewable energy systems, including solar panels and wind turbines, that offset energy costs and reduce carbon emissions. A facility powered partially by renewable energy can achieve carbon neutrality for significant portions of their operations. The shrimp produced in desert biofloc operations are versatile and premium quality. They're destined for diverse culinary applications across American cuisine. The most straightforward application is fresh or frozen shrimp sold at retail. Consumers prepare these in traditional ways: grilled, sautéed, boiled for shrimp cocktails, or incorporated into pasta dishes and curries. The large, uniform sizing and consistent quality make these shrimp ideal for home cooking. Food service is a major channel. Professional restaurants use these shrimp for signature dishes. The consistency and reliability of Biofloc farmed shrimp make them preferable to many chefs compared to wild-caught alternatives. A chef can order shrimp with precisely defined specifications and receive identical product every time, enabling menu standardization and cost predictability. Value-added processing represents a growing market segment. Processors make breaded shrimp, shrimp scampi, shrimp tempura, and other prepared products. These require the highest quality starting material, as inferior shrimp become apparent after processing. Desert farmed shrimp meet these requirements consistently. From a nutritional standpoint, shrimp is genuinely impressive. A 100-gram serving of shrimp contains approximately 24 grams of protein, making it one of the most protein-dense seafoods available. It's relatively low in calories, containing only about 99 calories per 100-gram serving. Shrimp is an excellent source of selenium, a critical mineral for thyroid function and antioxidant defense. It contains significant amounts of vitamin B12, essential for neurological function and energy metabolism. A serving of shrimp provides approximately 11% of the daily recommended value of iron and approximately 21% of the daily recommended value of zinc. Shrimp is also rich in omega-3 fatty acids, which have well-established cardiovascular benefits. While shrimp contains cholesterol, Modern nutritional science indicates that dietary cholesterol has less impact on blood cholesterol than previously believed, particularly when consumed as part of a balanced diet. The astaxanthin in shrimp, the same compound extracted as a supplement, is a powerful antioxidant. Research suggests that regular shrimp consumption is associated with reduced inflammation and improved cardiovascular markers. For American consumers seeking protein-dense, nutrient-rich foods that support health goals, shrimp is an exceptional choice. The availability of consistent, high-quality farmed shrimp at reasonable prices makes it accessible to diverse economic segments of American society. The emergence of desert biofloc shrimp farming represents something remarkable for American agriculture. It's creating high-value production in regions where traditional farming often struggles. Desert regions like Arizona, New Mexico, and parts of Texas have historically been economically dependent on cattle ranching, cotton, and commodity crops. These industries are facing headwinds from global competition, water scarcity, and changing market dynamics. Shrimp farming offers an alternative. A single facility generating 5,000 metric tons annually generates approximately $50 to $100 million in annual revenue. A 5,000 metric ton operation employs approximately 75 to 150 permanent employees, plus seasonal workers. For rural communities, these operations can be transformational. A shrimp processing facility in a desert region creates direct employment, attracts supporting services and infrastructure investments, and generates tax revenue. The ripple effects extend to equipment suppliers, logistics companies, packaging providers, and other businesses that support the operation. The investment required to establish a modern biofloc operation is substantial. A full-scale 5,000 metric ton facility requires capital investment of approximately $50 to $100 million. This includes land, facility construction, biofloc system installation, processing equipment, and working capital. These investments often come from agricultural venture capital funds, established agribusiness companies, and international agricultural investment groups seeking exposure to American agriculture. The profitability is compelling for investors. Well-managed operations typically achieve gross margins of 40 to 60%, meaning that after paying for shrimp feed, labor, utilities, and processing, 40 to 60 cents of every dollar in revenue remains. This is superior to most agricultural commodities. A 5,000 metric ton operation with 50% margins and product valued at $6 to $8 per pound would generate $30 to $50 million in gross profit annually. These economics have attracted significant agricultural entrepreneurs and investment groups. Several U.S. shrimp operations that barely existed 10 years ago are now among the largest and most profitable agricultural operations in their regions. The industry is also generating innovation in agricultural technology. American equipment manufacturers are developing advanced biofloc systems, water treatment technologies, and automation machinery. Some of this innovation is being exported internationally, creating additional revenue streams and positioning the United States as a leader in high-tech agriculture technology. Desert biofloc shrimp farming must meet rigorous food safety standards. These operations are subject to FDA regulations, state regulations, and increasingly, private certification standards required by major retailers. The FDA requires comprehensive food safety plans, often implemented under the Seafood Hazard Analysis and Critical Control Point System, commonly called HACCP. This requires identifying potential hazards in the production process and establishing critical control points where hazards are prevented or minimized. For shrimp farming and processing, critical control points typically include breeding facility hygiene, production environment management, feed quality assurance, harvesting procedures, processing facility sanitation, temperature control throughout cold chain, and final product testing. Processing facilities undergo regular inspections by FDA officials. These inspections examine documentation, observe procedures, and test products for contaminants. The standards are demanding. Any significant violation can result in product holds, facility closure, or recall orders. Beyond FDA requirements, many operations pursue additional certifications. Aquaculture Stewardship Council certification indicates that a facility meets environmental and social responsibility standards. Certified facilities are audited annually by independent third parties. This certification allows premium marketing and appeals to environmentally conscious consumers. Temperature monitoring throughout the cold chain is critical. Sensors in production raceways, chilling tanks, transport containers, processing facilities, and storage rooms continuously record temperature. This data is logged and maintained for traceability. If a temperature excursion occurs, the affected product can be identified and removed before reaching consumers. Product testing is comprehensive. Each processing lot undergoes testing for pathogenic bacteria, including Listeria monocytogenes and Vibrio species. Testing also screens for allergens and contaminants. Modern rapid testing methods can provide results within 24 to 48 hours, allowing quick product release decisions. Allergen protocols are essential. Shrimp is a major food allergen. Processing facilities must maintain segregated equipment and procedures to prevent cross-contamination with other allergenic foods. Packages are labeled with clear allergen information. The food safety systems in place at modern Biofloc operations are genuinely impressive. They represent the best practices in food production globally, often exceeding standards required in some other countries. This is a competitive advantage. American consumers increasingly trust products with transparent safety systems and full traceability. Despite the success of desert Biofloc shrimp farming, the industry faces real challenges. Energy costs represent the largest operational expense. Maintaining precise temperature control, running aeration systems, and operating processing equipment require substantial electricity. In regions where energy is expensive, this significantly impacts profitability. Water sourcing remains complex. While Biofloc systems recycle most water, they still require some makeup water to compensate for evaporation and other losses. Desert regions often have limited, accessible water. Some facilities have invested in treated wastewater systems or are exploring desalination. But these add cost. Competition from traditional shrimp farming regions remains intense. Countries like India, Thailand, and Vietnam produce shrimp at lower costs due to lower labor and land costs. However, American Biofloc operations compete on quality, food safety, and sustainability rather than price. This market differentiation strategy has proven successful. Workforce development is an ongoing challenge. The industry requires skilled workers who understand aquaculture, biology, engineering, and food safety. Building sufficient workforce capacity as the industry grows requires investment in education and training programs. Looking forward, the future of desert Biofloc shrimp farming appears genuinely bright. Several factors suggest continued growth. First, consumer demand for shrimp continues increasing globally, and in American markets specifically. Second, sustainability advantages continue becoming more valuable as environmental concerns influence consumer choices. Third, technological improvements continue reducing costs and improving efficiency. Fourth, investment capital continues flowing toward these operations, driven by their profitability and growth potential. Some experts predict that within 15 years, Biofloc operations could produce 20 to 30% of shrimp consumed in American markets. This would substantially reduce American dependence on imports, improve food security, and create thousands of rural agricultural jobs. Innovation continues advancing the industry. Genetic improvements are creating shrimp that grow faster and demonstrate increased disease resistance. Water treatment technology continues improving, reducing operational costs. Automated monitoring systems are becoming more sophisticated, allowing continuous optimization of growth conditions. Some operations are exploring integration with other agricultural or industrial operations, creating comprehensive circular economy systems. We began this journey asking how shrimp could possibly thrive in the middle of a desert. The answer is innovation, precision agriculture, and a commitment to efficiency and sustainability. What started as a radical idea has become a thriving industrial reality. From careful breeding programs producing genetically superior shrimp, through the controlled Biofloc systems maintaining perfect growth conditions, to advanced processing plants maintaining food safety standards that exceed global requirements, desert Biofloc shrimp farming represents modern agriculture at its finest. It's profitable, it's sustainable, it's scalable, and it's creating real economic benefits for American rural communities. The shrimp traveling from these desert operations ultimately reach American dinner tables and restaurants across the country. They're nutritious, they're safe, and they're produced with less environmental impact than traditional methods. For consumers, farmers, agricultural entrepreneurs, and American agriculture broadly, that's a genuinely compelling story. If you're interested in innovation in agriculture, sustainability in farming, or entrepreneurship in the agricultural sector, this industry represents the cutting edge of what's possible. The future of agriculture isn't just in traditional crops and livestock, it's in high-tech operations like these, producing premium products using precision farming methods. Thank you for watching AgriCraft. We hope you've enjoyed exploring the fascinating world of desert shrimp farming. If you found this documentary compelling, please like, subscribe, and leave a comment sharing your thoughts on innovative agriculture and agricultural entrepreneurship. What agricultural innovations interest you most? Let us know in the comments below. And check out our other videos exploring the future of farming. Thanks for watching, and we'll see you in the next episode.